day 2 of the Cinder part of the Wallaby PTG. Just a couple of business things. I forgot yesterday to do our team picture when we had happy hour, so we'll do that in the hallway after today's meeting when we go to MeetPad, because I can get everybody's face. So please stick around for that if you don't mind. All right. As far as the gate update, Grenade's been failing because of this Nova incompatibility between one of the libraries it depends on in Python 3.6. And Grenade has to run in 3.6 because it's got to do the perform an update from from U to V, and U still supports 3.6. I believe that's what's happening. So that's why you see the failure in Grenade. Anyway, I thought it was, I think I said it was in the gate yesterday, which was true, but it was in the gate all day, and they finally just force merged it this morning. So I've got a patch that I think I listed in the Etherpad. It's just a Cinder patch that will wind up running the test just to see, because somebody filed a separate bug against Cinder for Grenade being broken, but I'm pretty sure it was because of this other thing. So that's the only sort of open issue. And then Melanie filed a gate bug against Cinder today. I didn't have time to check to see if I got the impression it's intermittent, but I'm not sure. So we'll have to take a look at that later. But just in case anybody's interested, I put the bug up there. If it's intermittent, I'll write a elastic check thing, and we can see how often it fails. I'm hoping it's not like a showstopper kind of thing. So that's basically project type stuff.
So that bug,
yeah,
it looks like one of the LVM commands is seg faulting. So I don't know if that's a Cinder bug, but it's definitely odd.
Right. Yeah, I'm hoping it's not seg faulting a lot. But, okay. Okay, well, hopefully for the next few hours, we will just pretend that that bug doesn't exist and carry on with our Cinder type business. All right, we got 20 people. People who've come in a little bit late, just remind you the team picture will be right after this in MeetPad if you want to participate in that, and I encourage you to. And then, I'm looking for Jay's going to be a little bit late, but he's got the first item because he was going to talk about some updates from the TC meeting about things we were talking about yesterday. But we can actually put those in later. But I do want to, before I talk too much, I want to just take a moment. Does anybody have any follow-up from yesterday? And also just remind you that there's a section at the bottom where we can put additional topics. So I think we're going to cruise through this stuff fairly quickly, the amount of topics we've got. So we're going to have a bunch of free space on Friday. So if something occurs to you that you want to discuss or you want to revisit, please add it to the bottom of the Etherpad. I didn't check to see. Yeah, so nobody's added anything yet. But anyway, be aware that that's there as a thing, and we can rediscuss. We can discuss new stuff or rediscuss old things that have been already discussed but need some more. Okay, since Jay's not here, let's go right ahead and discuss the new driver. So the Kioxia team is going to propose a new driver. It's got some requirements that make it a little bit different from some of the other drivers. So they are going to explain what their technology is like and how they see it folding into Cinder, and then we will hopefully have plenty of helpful suggestions for how they can get this done. So I think, does somebody want to share?
I'll share.
Okay.
Here, hang on. And nursing my cup of coffee here in the dark in California.
Okay.
All right, so open system preferences. Okay, let's try again.
Hey Brian, I'm on now.
Oh, okay. Well,
Sorry for being late.
Do you want to go?
Up to you. Do you want more time to wake up?
No, I'm just having permissions problem with sharing my screen in Jeans. Let's see. Is Zohar? Can you share your screen, full screen of the slides?
also, if those were in, if they're in Google, whatever they
Yeah,
call
it's the same Google Doc. Can you share those?
it, I would have to find it. What I was thinking was, do you mind posting the link and then people can just
Oh,
sort
I
of
don't
go
mind.
through it? Okay, that'd be great because then it'll be, yeah, if you put that
Okay.
on the Etherpad and then
Yeah, go back to the beginning here. Okay.
Blue
Great.
Jeans has, so yeah, one thing about Blue Jeans is that when you share, you see the shared stuff, but you don't see anything else, which makes it pretty disconcerting.
Yeah.
So, okay.
Okay, so I'm going to go pretty fast because I know you guys know all this stuff. So first, here, can I click or, yeah. First thing is who's Kioxia. We actually invented NAND flash. We used to be called Toshiba. We had to sell off the flash division because of huge nuclear power plant debts in Japan. So we now have a new brand, but we have a long history of flash as a storage media. And are somewhere around the third of the world's output for flash devices. Next slide. In 2012, Intel and us and a bunch of other people in the industry invented NVMe, which was the first major reinvention of the block storage interface since SCSI in 1982. We let's go back. Yeah. What is it? No, NVMe. Yeah. It has a number of efficiencies that add up to low latency and high sustained throughput. A lot to do with the way the protocol works and its efficiency and high degree of parallelism. So we believe it's a game changer for storage generally in terms of its efficiency. So next slide. The next thing that happened was 2016. We got NVMe extended over fabrics, which now it works over Fiber Channel, TCP, and InfiniBand. And support for this is included in the driver, the Linux kernel 5.0, and it's available in all the major OSs, both Initiator and Target. And there's an Initiator on Windows as well. So go back. I know we're excited to go fast, but so one of the key attributes here is this remote fetch from another device happens without a lot of CPU requirement on the Initiator side. So that's a kind of a distinguishing feature, and it adds up to very low latency remote access times on the order of a direct attached storage. So what is Kumoscale? Next slide. So Kumoscale, typically we're selling into people who have a lot of direct attached storage, that is, these flash devices smeared across their compute nodes. And they're, in terms of having a cloud native commodity type devices, the options are really either Ceph or a very high end appliance that does all the resiliency in the box. We don't do that. We let you disaggregate the storage into a standard white box storage node that then is giving you much better utilization of these devices. And just to give you a sense, we have customers testing right now flash devices on the order of 30 terabytes. So the idea that a single workload in some kind of direct attached model is going to be fully utilized by the workload is kind of crazy. You want to take this resource and share it across a lot of compute nodes. One of our values is being very effective price performance. So these are low-cost white box nodes, and we give you very high native to the wire NVMe OF performance, and that lets you support more users per backend, and that gives you lower operating costs. So that's kind of what we target tier 2 data center providers, and we're enabling disaggregated storage. Next slide. So in a data center, in the environment we sell into, we have a centralized point of view of all the storage nodes, the cluster, and then we take telemetry and make intelligence decisions about the media and for optimal placement across the cluster. So that's what we focus on. It is really focused on giving you best possible NVMe OF native performance. So once the workload is connected to a target, it's on the wire, nothing in between. So next slide. So what we're hoping to do in this, what we're going to talk about in a lot more detail today with Zohar is we're hoping to enable our approach that we've done in Kubernetes and on bare metal. We're hoping to enable this on OpenStack. And in our model, the way we we use MD RAID on the server to basically do a RAID 1 of multiple backends in the case of replication, and then the 3 writes are happening in parallel to those backends. If one of the backends goes down, we can see that, and we just reinstantiate one of the replicas on another available backend. And so we just have a little bit of functionality we need from the server point of view to configure that MD RAID and then monitor it. That's the kind of new thing we want to discuss today. And that lets us, do this self-healing. It lets the write occur in parallel. It lets you get, across multiple failure domain resiliency. And from the point of view of the local application, it just sees a single logical volume. So this lets you have the storage layer, give you resilience, even though the backend nodes can fail. So to talk through the idea, Zohar is going to go through a lot more detail in this. So take it away, Zohar. Any questions on this so far? Is the concept clear?
Yeah, I think so.
Okay.
And
So go ahead.
Don't worry
Sorry?
about being too speedy.
Yeah, I know you guys are fast. And I don't have the technical details in this drawing. I'm just trying to show you the concept. So go ahead, Zohar.
I think Brian's saying we got plenty of time though, right?
Yeah, sorry. What Jay
Yeah.
said. I'm saying you don't have to rush.
Yeah.
So
Oh, okay. Sounds good.
this is good.
I
So
think we will have a lot of.
So I think the basic architecture is pretty clear. Did anybody have any questions before we go on though?
So I did have one question. I mean, I've heard of Kumo Scale, but I guess I'm not aware of what you guys have been doing with Kubernetes previously. Is there a 1-minute pitch on how it's been integrated there that might give some perspective?
Yeah, we do. If you replace Cinder with CSI and then you have that long arrow connect to the provisioner, that's what we do today. So
okay,
we're just able to use the Kubernetes, agent, if you will, to do that.
Okay, so you've got a CSI driver then.
Yeah. And we're on the list of supported CSI interfaces. So this works in the Kubernetes world pretty well, but it's partly because they have a thingy out there that lets us do this.
And so Kumo Scale used to be branded as Toshiba, right?
Yes.
Okay.
Well, no,
all right.
It was always Kumo Scale. Wait, it was OCZ, and then Toshiba acquired them, and then Toshiba changed their name. Kumo Scale
was Toshiba. Kioxia was Toshiba. Kumo Scale is the product. Kioxia is the company.
Yeah. Right.
Okay. Gotcha.
We're still, the headquarters is still in Japan, and so Kioxia is a name that makes great sense if you speak both Japanese and Greek. We're told.
Yeah, and we have lots of fun with time zones, between the headquarters in Japan and dev team in Tel Aviv. So, and I should have introduced everybody. On the call with me today is my boss, Joel, who just spoke. We have Oded Ilan, who's the country manager of Tel Aviv, and then Zohar, who is working with us on this proposal, and Yaron Klein, who's effectively CTO of the Tel Aviv team.
Okay.
So Go ahead, take it away, Zohar. You know Zohar, so.
Thank you, Chuck.
Yeah.
So Chuck just went in over all of the benefits of NVMe over Firebrick, how it's good for scale-out cloud storage running on commodity hardware. So we are here to contribute this functionality and, in general, our expertise in NVMe to OpenStack. So the plan is to natively integrate this scale-out resiliency into OpenStack. And this is going to work with our Scale provisioner, being the provisioner where the Cinder driver asks for volumes and provides them and connection information. But not only, our goal is not to only benefit our Cinder driver and our backend, but we want it to be useful for all NVMe or RAID users in the OpenStack ecosystem. So to the driver itself, yes?
Your hand is kind of in the way of the camera, so we have a really good view of your hand, but not of your face.
Yeah, I cannot see my own camera because the whole screen is taken by the bridging.
So that's why I'm telling you we see your hand really, really good, but keep it out of the way of the camera.
It's in a very unfortunate position, but okay, we'll make do with what we have. So okay, going into the driver itself, similarly to other drivers, including the NVMe connector and the Nova libvirt driver for NVMe, the OS brick connector is what is used to first attach the volume on the compute host and to expose it to the hypervisor. So in our case,
Zohar, you might want to point out we already have a working Cinder driver.
Yes. So we already have a working Cinder driver. I will mention it a little bit more going into it too. But this is the Cinder driver. This is also the proposal we want to support. So our working Cinder driver actually works with RAID over NVMe as well. But we also want to enhance the existing NVMe driver and support even bare NVMe or just standard NVMe volumes as well. Which in our case, the RAID, of course, is much more important, having the RAID over for resiliency and replication, and we will go over all of that. But the idea is to enhance the existing NVMe connector, which is upstream, and build on top of that. Rather than basically replicating it and just rewriting it separately in their proprietary driver. So our approach is more enhance the NVMe driver and build on top of it. So the part that we build on top is the RAID over NVMe, and as Chuck was describing, this is part of the value proposition of Scale, and there's a bunch of benefits. There are trade-offs, but there's a lot of benefits to doing it this way, where the client or the storage consumer, the compute node, is in charge effectively of doing the replication. Because now we are free to allocate volumes wherever we want, and it's really up to us. That's why we can scale out. Similarly in the diagrams we saw before, where a single compute node on one of the racks replicates data to it looks as a single volume, but actually is replicated across different racks, across different storage nodes, those racks. So for this, we're going to need the connectors. So there is the NVMe connector, and we have some enhancement we want to also contribute to it, which it works well with the Scale provisioner, and it's an optimization in general in the NVMe world. So this is NVMe connection sharing. And of course, the second part is the host storage replication or the RAID on top of these NVMe devices. So that could be maybe two separate blueprints and two different pull requests. We're open to any kind of feedback on this as well. And of course, with all of that, we also want a third-party CI that is, not just for show. We want to be useful. We want it to run against our backend and show that everything is okay in whatever CI run and all the testing that has to do with it. So now going deeper into expanding the NVMe connector. So we want to enhance it, and we want to add this connection sharing feature. So currently the existing NVMe connector in OpenStack upstream, in OS brick repository. It opens a new connection for every volume. And the way we do it in the Qmoscale, also in our existing prototype, as part of OpenStack integration, what we do is we open a single connection for any pairing between initiator and target. So we effectively save on connections. And with NVMe, which can have thousands of connections per node or even per device, this can be a very big optimization. So the second part is adding the support for the compute host RAID replication. So that's the more tricky part, but we also have this working in our, let's say, in-home prototype, but there are a few design directions we could still take feedback in here. And on top of that, this whole functionality of RAID is what allows for the whole self-healing component, which is also part of our storage solution, and which we will also go into very soon. So handling the replication part, the RAID. So again, it's useful for scale-out storage. We already saw why. We have an existing prototype, which is this connector that not only does NVMe, but it puts those NVMe devices into RAID arrays. And we want to make it as modular as possible. We want to enhance and expand on top of the existing NVMe driver. Now, there is a little bit of a consideration here too, and maybe we could get some feedback on this, especially, is with this approach of NVMe plus MDADM connector, we end up having a coupled connector, an all-in-one, both NVMe and MDADM. In my opinion, ultimately, doing RAID on the host can be beneficial in general, not necessarily as part of a specific connector. So it could be a separate connector, it could be a feature of the NVMe connector, or it could be this all new feature of replication, storage replication, that maybe in the long term, that's the direction it can go into. But right now, we definitely have a working prototype. We want to make it as modular as possible. So that's why, but there's still room for discussion here. So there's some questions like, should the RAID replication live in its own brick connector, in its own OS brick connector? And now it's the NVMe and MDADM, the RAID part are coupled together into one connector. Is there a way to decouple it that is also inherent of OpenStack philosophy? Can we make it more modular? And also, is there existing replication features or systems in OpenStack that we might have missed, that we might be able to utilize? So any kind of input on this direction will be valuable. Or any questions so far? So we will get into a bigger picture. I know this is a lot of points coming together, but we will get into a big picture thing, and we'll be able to kind of put it all together soon. Sorry, anybody had something?
Yes, hi. I've got one question. So in Etherpad, you said that it's pretty different from existing drivers in Cinder, but looking at your slides and existing SPDK driver, it's pretty same if we are talking about driver architecture. So what actually are differences?
So the driver stays the same. The driver, all it does is request for provisioning of volumes and then passes on the connection information. But the difference is the connector that the driver relies on, or not just the driver, but really the libvirt volume driver. So this connector is adds this RAIDing capability on top of connecting to NVMe as well.
Okay, it means from Cinder perspective, it will be a pretty standard driver.
Yeah, so from the driver perspective, it will be a very standard driver, yes. But
okay.
The point is that we are also introducing some changes, enhancements and expansion to the NVMe OS brick connector. So we are going to need a new connector that does some of these extra features that we were going over.
Okay, got it. Thank you.
So that is a change in the OS brick repository, whereas the Cinder driver, when it will be in tree, it will be in Cinder.
So it'll be the job of the brick connector to set up the RAID setup.
The job of the connector is to set up the RAID. And also there's an agent which will be doing healing stuff, which is what we'll get into next. So that he will also deal with RAID. Yeah, so that is another part, right? So again, the big picture wise, there's besides the previous questions that I asked just about decoupling of the RAID part and the NVMe part, there's also the coupling or decoupling of the agent and this MDADM functionality. So for now, I will get into this soon. Any more questions so far?
What level of RAID control are you talking about here? Is the because there's multiple different levels.
It's just
right?
RAID 1. This is mirroring.
Yes.
Okay, so you'd have two volumes and then setting up RAID between those two for.
No, it's just mirroring. It's treating each target as if it was a mirrored local disk, but it's actually going over NVMe OS. So from the client point of view, it's a single logical volume that is mirrored across however many replicas you've requested. And this is only in case of redundant volumes. You can have simple volumes, it doesn't always have to be replicated. But for replicated volumes, this is just a normal RAID 1 from the point of view of NVRAID.
So on the host that Brick would be managing, it would still only see one volume, but you would set up RAID on top of that?
Yes, so logically for OpenStack metadata, OpenStack, in its own format, will see it as one volume, but under the hood, there will be connection information for 3 NVMe devices, but they will also get raided into one volume. So there will be one RAID device which will get passed to the hypervisor.
So basically, it's like multipathing, right? You get multiple devices and a device mapper on top of it, and it's the device mapper, the one you pass to Nova.
The only difference is that it's not multiple paths to one device, but it's multiple paths to multiple devices. That's really the difference.
So this is a little bit confusing for me because OS Brick is currently operating under the assumption that each connection request that comes to it is working on a single volume. And that's why I'm asking if the RAID device that this connector is supposed to be setting up is supposed to work with multiple volumes. OS Brick doesn't have that capability currently.
Yeah. Okay, so this is a very good question. And what's happening here is that through OS Brick, when it's being told the connection information for a volume, he actually only sees one volume. So in the language of OpenStack, these 3 devices that NVMe devices are actually one volume. So in the backend, in the storage backend, there are 3 different devices, but in the language of OpenStack, it actually ends up being one device. And under the hood stuff, let's say QEMU scale specific or anybody else that implements this specific connection information, even though it's single volume, you are giving a connection information to 3 different targets, but it actually is effectively just one volume.
So OS Brick, when the initialized connection call is made to the driver, it's going to return information that for 3 specific volumes, and the connector is going to attach those 3 and then create a RAID on top of those, and then return that as a single device to libvirt?
Yes.
Okay. I guess that's what I was really asking. That's where I was confused. Okay. No, I guess that makes sense. I mean, yes, you would need a new connector to support that understands that it might get N volume descriptors coming back in the connection info, the driver.
Yeah. Okay, thank you. So this is actually an interesting point because we can go into deeper. So now that we established this, so we will actually go into this slide, which we'll go over. But I also just want to give the main point for the agent as well. But just the idea of the NVMe plus MDA-DM coupling, that's not trivial here. So what you just said, yes, it can be true, but it doesn't have to be. The NVMe and the RAID part don't have to be married together. And right now they are, but maybe there are better ways of doing it.
Okay. Can this support multi-attach in this scenario too?
Sorry?
Does this also support multi-attach in this scenario too?
Multi-attach, it should support it. I'm not sure. Maybe Yaron, you know.
It's not a requirement
I don't
that a driver supports it, but I was just
support multi-attach. Yes, we do.
Yeah, I don't see why it shouldn't support multi-attach. I mean, if NVMe supports it, then that's basically. Okay.
It's required also for the migration, the multi-attach. So.
Yeah. Yeah. So on the QMuscle end, the provisioner is very serious about that. So it's dedicated to doing the scheduling and provisioning of the volumes. So that's the whole point. It should take care of any kind of edge cases that might arise. Maybe race conditions when you're doing multi-attachments. Okay, so can I continue to this? This is kind of the last main component, and then we'll kind of look at the whole big picture. So the monitoring or healing agent, we should really call it healing agent, but it does do some monitoring. It just watches the state of those devices, in NVMe devices in this case. So it's in charge of the auto-healing or self-healing of attached volumes. So we got a volume, we got its the connection information for all of its replicas, and now we're already connected to VM. But let's say one of these connections got severed, or anything happened to one of these three pieces of the volume anywhere along the data path. In that case, for OpenStack, for Nova, Cinder, nobody is going to notice this. It's only going to look as like a degraded device. So yes, if you do the MDA-DM status, you look at this RAID device, it's going to have one of its legs, one of its devices in its array as degraded, but no one else is going to notice this. So that's why we want this healing agent, and it is part of the QMuscale solution. So it only makes sense to add this here. And I think this is also a good kind of strategy moving forward for, in general, just data replication. For scale-out cloud storage, really not necessarily for QMuscale at all. So because nobody sees this, we need something to monitor this state. So even a degraded RAID device will still be functional to the VM, the hypervisor that's consuming it. But we definitely want to do some healing, and especially self-healing, as much as possible. So we monitor in these device states. We see a device is in a degraded state, and then you can do some different tweakings of timeouts and things like that. But we inform the provisioner of this degraded device, and we request a new replica. And then once the new replica is available, we basically connect to the new replica, we detach from the bad one, and now we have a fully working RAID again. And this still all looks like a single volume to Cinder. The difference is that in the connection information, now the replicas have changed. So how can we fit this monitoring, this healing agent into OpenStack? So there are some pain points here. One easy way of doing is just running this daemon agent, but for different reasons, we want to keep it in the upstream OpenStack, and we want to integrate as well as possible. And this opens the door for this kind of replication and self-healing of volumes, not only using the QMO driver. So, okay, so this was, yes, sorry?
Is this daemon required for all of this to work? And is it open source? What is the license?
So there we go. This is a great question. So I'm completely for making it open source. That's one. So I don't know exactly what's the license. Maybe Yaron.
We would be delighted to open source that functionality.
Okay.
And is it required for the daemon to be installed on host for all of this to work?
It's not required. Everything will work, but the healing will not happen. And since nobody sees this RAID device being degraded, since the RAID device is still functional to the rest of the OpenStack infrastructure that's consuming it, specifically to the hypervisor and the VM, it looks like the volume is working, everything is working, but there is actually one of its legs is actually broken. So that's why we want this healing agent. So everything will work, but except for self-healing.
Well, so there's probably a number of ways you could refactor this functionality. You can monitor something without a local agent by logging into it periodically and assessing its status. That creates lots of network traffic and has security implications and stuff. So saying, is it necessary? Some equivalent of it is necessary. We could say it that way. But basically, you need, this is, you need, the functionality you need is notice if something goes wrong and then cooperate in fixing it. Our provisioner will sequence the activities associated with a healing operation, creating a new volume and disconnecting the old one and all that kind of stuff. But it needs some way to talk to the compute node and accomplish those things. And I guess one thing that we haven't talked about explicitly here, but should that be directly between our provisioner and the compute node, or should it be through the Cinder driver?
Through any component of Cinder.
So I would guess that it's going to be more from the provisioner side and not driven by the Cinder driver, because it's, I think, kind of outside of the scope of what it really needs for the Cinder driver to just work. And if we go back to the multipath analogy, I mean, we don't currently have things that poll multipath iSCSI and try to react to paths being down and that kind of thing for Cinder volume connections. So
there's multipath D. So that also kind of happens.
D does all of the daemon work for that.
Right. We don't get that Cinder side to monitor it or react to it. So it's useful, monitoring stuff, but I think it's kind of outside of the normal realm of Cinder driver activities.
Yeah, so we don't want to put it into the Cinder driver, but so one thing that
you might want to
is,
go to the next slide, might help you.
Yeah, let's do it. So okay, we can take a time to take a look at this. Can you guys see my mouse? Or no?
Yes.
Yeah, we can see it.
Okay, so right now we have this, but a better coupling would be, and not necessarily like this, but doing something here. So we're open to feedback, basically. But this
if the agent isn't required for this to function, then it really doesn't matter to Cinder, right? I mean, the only thing that I guess I was concerned about is, what level of licensing is required if this is a required component of this whole entire architecture to work correctly. and that would be concerning to Cinder. But
so I think for this discussion, we should assume that the answer is yes, it's required. There's some asterisks attached to that statement, but let's operate under the assumption that yes, it's required and it'll be open sourced and provided to the community, and just sort of say technically how's the best way to implement, because a RAID system that can't correctly respond to a fault isn't really a RAID system, right? I mean, it has to be able to actually heal itself, or it's not doing its job.
So based on the picture you have here, though, it doesn't look like there's any direct interaction between Cinder or OS Brick with the healing agent. It's actually interacted with from your provisioner.
Yes, that is correct. But first of all, we can have a common interface here for the healing agent and OS Brick. So the provisioner, actually the action starts on the healing agent. So the healing agent is the one that checks the status of the RAID, and he is the one that sends requests to the provisioner. So that's why we need him here. And there is a lot of commonality between him and the OS Brick connector. So a bunch of this code, which is actually the bulk of the code of both of those, is gonna have to sit in the OS Brick connector. So this part is unavoidable completely, even if we yank out the healing agent completely. However, a lot of this code is actually common to both of these. So this is one of the reasons why I think it does make sense. So this new code, whether it will just live in its own OS Brick connector, or maybe it will be a library that the OS Brick connector will use and the agent will also use. But there's a lot of value, I believe, to this code. So maybe to future enhancements to allow this kind of healing mechanism to be native to OpenStack. So even the multipath example, sure, the multipath D agent is not internal part in tree of OpenStack, but relying on it and all the connection information that is necessary for it is part of that. So similarly, we can still keep it this way, but it can still be something that is part of OpenStack. Similarly, like OS Brick is part of Cinder, but it's actually it's not always actually talking to the Cinder driver, right? So it's a kind of a similar situation here. So the OS Brick repository can be used by a host that does stuff for its own storage without even following the control path of Cinder, with all of the, allocating volumes for VMs, et cetera. OS Brick connector can just, even though it is, at least as far as I understand, maintained by the Cinder community. So it is part of the Cinder project, but it actually doesn't really follow the control path of the Cinder driver, at least indirectly. So in the case, for example, if you have a libvirt driver that uses a connector, then we end up having a path that does get some data from the Cinder driver with the connection information going into the OS Brick connector. But in many other cases, connectors are used only for the host local storage, so not without even a connection to a Cinder driver.
Would this work in the case of boot from volume for bare metal? And would the agent still be required in that case? Because that's a kind of an edge case.
Well, we support bare metal as well. Yeah.
Yeah, so we definitely support bare metal, and we do want to say for the purpose here that the healing agent is necessary, but with an asterisk. So in a way, it will work without it, but for a real production solution, it's necessary. We're talking about cloud. We're talking about self-healing resilience. So this is the reason why we for this purpose we just say it's necessary, even though technically you can live without it for a short time. But in a scale out big system, things are bound to fail. We basically need this.
So in the case of the live without it for a short time, could you boot a bare metal box without this agent and then install it after the image is up and running, and have it
Yes.
discover and find things correctly, or is that going to be required as part of the image for actually?
So boot, I mean, boot implies that the BIOS can, can interact with this storage system without help, right? Because you're booting, and so the system isn't running yet. Obviously, there are no BIOSes that have this capability built in. And in fact, BIOSes today, I don't believe natively even know how to boot from a local NVMe drive without an external, looping out to an external NVMe driver. So to make boot work, even on any NVMe device, is a little bit of work. And doubtless the way you would do that here is you wouldn't necessarily need a replicated, protected boot device. You could, create a simple NVMe over Fabrics volume accessible over the network. That's the boot device, and then if you want a protected, volume to add later, you do that once you're booted up.
So I think this is going to have similar limitations to Ceph as far as bare metal boot from volume goes.
Right. I mean, this is really kind of a more it's a generic version of Ceph. I mean, Ceph architecturally is very much like Kumoscale in that it's based on kind of off-the-shelf hardware, which means the hardware nodes can fail. But Ceph has its sort of crush algorithm, which is the node local piece has been boiled into Linux, and so it has that advantage. This is kind of generalizing the architectural ideas of Ceph to make them work.
Yeah, it would be nice to have this whole component, the whole CLI and the libvirt stuff, and based on the Linux kernel. Ceph basically integrate the libRedos with Linux. So once we can do that, then it will cut us a few corners. So that would be really nice. And we won't even need the OS brick connector. At that point, we'll just have our own libvirt driver, same like Ceph does.
Well,
so
let's not get ahead of ourselves.
Yes.
I may all be retired by the time that happens.
Except that we still want to be able to support this for bare metal too.
Okay.
So just a question I have: if this agent and the connector were, if you draw a circle around those and say we'd like to deploy those in the Cinder context, is it a problem for our provisioner to communicate directly with that entity around the Cinder driver? I mean, is there a precedent for that?
You mean the Cinder driver talking directly to the connector on the remote host?
Well, that's the standard path, right? The Cinder driver talks to the connector. It is kind of the normal course of events. True?
Not exactly.
No.
It doesn't. So that's why it's drawn this way. So Cinder driver is part of the Cinder control plane. Yeah. So Cinder driver part of the Cinder control plane, and when we so there is some Nova schedule. So we're scheduling a new VM, and we are provisioning a volume. So this happening in the OpenStack control plane. So let's say the dashboard Horizon sends a request to the OpenStack API requesting the creation of allocation scheduling of a new VM and a boot volume for that VM. So the boot volume request goes into the Cinder driver, and the scheduler decides where to do this. And now the information is passed down this control plane to the Nova compute component together with the connection information. So, and then this connection information via Nova is passed to the OSBrick connector. So there's just one request that goes basically into the Cinder driver from the whole control plane, which is provision the volume, and it gets back the connection information, and then all of this is passed to the Nova compute side.
In order to make this work, do we need to then make
So
some changes to Nova?
Well, no. So that's the good part also. That is not necessarily. There could be some changes to Nova. So this is actually one little point about how to deal with the OS brick connectors and the two flavors of connectors we have. So this is something I will get back to because it's one of the questions. Thank you for reminding me. I want to ask. But back to your point about treating these as one entity, Cinder driver still has its place. It just doesn't have to be talking to them directly. So the Cinder driver talks to the provisioner, and the healing agent talks to the provisioner, but the OS brick connector and the healing agent both share a lot of functionality. So that's why, in a way, it's one entity. And actually, the way we have it working right now is that this connector talks to the CLI and does the management of the RAID, and the healing agent does it. But another way of doing this is having an agent that takes care of all of this management, and the OS brick connector actually talks to the agent. Okay, so now if this agent part, not necessarily just healing agent, but if that was part of the OpenStack, so the whole thing would be native. So either way, these libraries that are here for OS brick connector to use, these are useful libraries that can be used, that can sit in the OS brick repository.
I have one question. Shouldn't the OS brick connector actually somehow tell the healing agent to monitor a specific device?
So that's a good question. So right now we can, in a simple case, we can just assume that all the RAIDs that the healing agent have created, they are all managed by OS brick.
Yeah, but
so
the healing agent is not the one creating them. It's OS brick, right?
Yes.
So OS brick creates the RAID, and it's the one that is going to pass to Nova. That before passing, it should tell the healing agent to monitor it, because the healing agent should not assume that all the RAID systems, all the RAID belong to scale.
Right.
That's a great point.
Yes,
that's a great point.
I think there that don't belong to it.
Yes, that's a great point. I think to answer the current state of this, I think maybe Yaron will know better about our current prototype and the way the healing agent works now. But what you're suggesting is basically a connection here, or in a sense, treat this as a more integrated entity, both of these parts together. So that's a great point, and we shouldn't assume it this way. So if we do assume it right now in our current prototype, this is gonna get fixed. So thank you for this.
Okay, sounds good.
Also,
I think the fact that... Sorry, Walter.
Yes?
That's okay. We also have to make sure that the healing agent doesn't expect Brick to be there to talk to Nova and or Cinder at a later time when it's healing any of the paths as well.
Yeah, precisely that. I was going to say that with the explanation that Sohar just gave, it is nice that it will not assume that, because it is going to talk to the provisioner directly. It's not going to talk to Nova. It's not going to talk to Cinder. And their Cinder driver is going to be smart enough to know when the healing agent has replaced one volume with another in a node. So they will have to query their backend and see, oh, I had these 3 volumes before, but now one has been replaced by the healing agent, so they will do their thing and work.
So Gorka, this is going to hit the...
Sorry. And even further down the line, when a detach call is made from Cinder, that the detach of the volume list that gets passed into OS brick from Cinder is up to date somehow, or there's a way for OS brick to reconcile the differences, because Cinder is going to have the original list of volumes that it has that it's trying to tell the compute host to attach to, and the healing agent is going to replace one of those volumes at some point, and those lists are going to be different.
Yeah, but the main device is the same. the parent. It's like in multipath. Your parent is still the same. You can just get the children and figure things out. Yeah.
Yeah, but the connection
at that
information.
point, OSBrick looks at the multipath daemon to give it the list of volumes that are underneath it at the time during detach.
Mm-hmm.
Yeah, here they would look at the MD rate information.
Yeah. Okay.
Yeah. Yep, that was just going to be my point as well, because on the Nova side, we're going to cache that connection info in the initial attach. It's a problem we hit with Ceph all the time if people change the monitor IPs, for example. Not every action in Nova actually results in that connection info being refreshed. So as long as we're looking at that initial logical device that's returned, that RAID device, and not the individual paths or volumes or whatever we're calling devices underneath that, that should be okay.
So we basically need some more awareness here, or in the interaction between these two, and this is kind of what we're asking for, this kind of feedback, and how can we do this integration better?
I think for getting this done in a reasonable amount of time, you would want to go with this approach where you skip the whole communicating with Nova and Cinder. In the future, maybe we add some health information gathering to OpenStack where we can gather, for example, for multipath, when paths go down, things like that, so that administrator can get warnings. But since we don't have that, adding that just to make your healing agent work would take a lot of time for you. So I think it's better this approach where you skip Cinder and talk directly to the provisioner. One important thing is that I assume you will have to pass some kind of credentials to the healing agent, and that should not be passed through the connection information. Just a reminder, because the connection information can be retrieved maybe by people who don't have actual access to the cinder.com file.
So the provisioner then needs to participate in the OpenStack, security system, TLS certificates, or however it's done?
No, actually, you can just on deployment, if you write your own configuration for the healing agent in your system and give it the right access, it should be fine. What I mean is that given the structure that we have in OpenStack and how OSBrick doesn't have any connection to Cinder, and how the information that gets to OSBrick should never contain full access to a backend, in this case the provisioner, you have to go around it. So you have to have that information already on the compute node. And you cannot do that on the running system. You have to do it at deploy time.
So where would the agent run in this proposal? It would be on physically running in what the context?
It would be running normally in the host, but let's say it would look into Etsy, QMOScale, that's config.yaml, I don't know, where it would have the actual access information, the credentials to access the provisioner.
So it would be like a daemon service?
You need it to be a daemon service because OSBrick can disappear. It's a library, so it is not constantly running. And what happens if you're updating Nova Compute service? You bring it down, but you want your healing agent to continue running. So it needs to be an independent daemon from where OSBrick code is actually running.
So how would this be viewed by someone who's deploying OpenStack? I mean, would this be part of Nova or part of Cinder, or how would this be?
Well, depends on how if your healing agent is integrated into OSBrick, then all they would have to do is add a post install code that on every Nova Compute node, they could insert your configuration file to access the provisioner. That could be it. Write a config file there.
Okay.
And it would also have to be deployed on the Cinder nodes too, most likely for copy image to volume and volume to image operations as well.
If they are going to be running the healing agent there as well, yes, yeah. So,
okay, I'm going to stop asking questions. I think I'm going to slow us down here.
So one thing that we've heard from, let's say, large-scale operators, that they don't want any bits, custom Kioxia bits. They just want the seal of approval of OpenStack. And if we can have the healing agent, so assuming we're going with this approach, which is the simplest approach, and I do agree with you on that too, Gorka, I believe. Assuming all of this and these requirements, we can just have the healing agent live in the OSBrick repository, but we would need a change in Nova to basically start it up. Am I getting this right?
No, Nova wouldn't be responsible for starting that. That's deployment time.
Yeah, you would need, or either you do it at on the installation, or you get your OSBrick connector to check it and spin it up, like we do with PrivSep, where we can start PrivSep automatically if it's not already running.
Okay, great. Yeah, that's okay. So basically, the first invocation of OSBrick to check if it's already running, and otherwise just start a new one.
Exactly.
So this is something acceptable. All of these changes added to OSBrick, this is something that would be acceptable, and you guys will be willing to review and go forward with.
Yeah, I think that for the sorry, Walter.
Sorry, I think the location or placement of the healing agent code, I'm not sure having it live inside of Brick, depending upon how large it is or whatnot, makes a lot of sense. But that's something that we could discuss. I mean, as long as it's open source and the same license as everything else, I mean,
yeah, that's the goal
a home for it.
Great.
Cool.
I was thinking on the OSBrick connector aspect that maybe since the NVMe plus the RAID can be a generic thing, whereas the adding on top of that the healing agent is not generic, because your healing agent will be specific right now to the QMO scale. Maybe you can have two different classes, the generic class, which is the one you have, and then on top of that you add a new connector type, which is your specific connector, which handles the healing agent thing.
Exactly. So we could have something right here where my mouse is pointing. So we can have a generic healing agent that has a set of API, and we implement our API right here. So when the healing agent says, "Hey, I need a new leg for my RAID," he calls our specific driver for the healing agent, the KS driver, agent driver, and that actually does.
Yeah, that could be even better.
Mm-hmm. So this way it will be pluggable, and anybody else will basically be able to use it. So I didn't draw it this way because we don't have it this way right now, but this is the idea in the larger sense. So again, it's a little bit more complicated, but it's worth it. And if anybody else starts using it, now we're making a new trend of adding more resilience features to volume.
And I'll point out this sets you up for as NVMe OF evolves. That whole layer there's a lot going on there, and I mean, there's a lot of features coming down the road that this sets you up to support easily in a generic way.
Cool.
Okay, so any more?
The last remaining question that I kind of sort of had is CI with all of this.
Okay. Yeah. So well, fortunately the driver interface, the driver spec remains the same. So technically the driver just stays the same, right? We will need this component. So that's the other extra effort in the source code part, right? So this is really the other part of this effort. So the driver is just a standard driver, but we do need this component right here, the OSBrick connector at the very least. Now, once we got this up, then we'll have our own, of course, backend running. And, we obviously could use input, what's the latest way of doing it. Several years ago, I worked with Nexenta, who did a double-nested OpenStack environment where every request for new Tempest run basically would spin a VM in which will install DevStack and then do the Tempest run in there. But it will connect, let's say via iSCSI to a physical appliance that's in the same network. So I don't see why it should be very different from that.
Okay,
It
cool.
shouldn't.
I've seen Zool V3 that has a Docker Compose for setting up a whole environment. So you might be able to utilize that as well.
Nice. Yeah. So any input on this, we would love it. So this is basically, besides obviously implementing this and getting this code into a pristine state, let's say, this is the main effort, is running the CI.
I assume for human scale, you don't do multipathing and be multipathing, right?
Yeah, well, we do. We support multipathing at the network layer, yeah.
Okay, so maybe, okay. So it's not out of the question adding that feature in the future to always
that's what I'm
break
trying to.
Okay.
Asymmetric namespace access, NVMe OF itself is evolving with a different form of multipathing. So this would set you up to actually support that kind of capability generically. Yeah.
Mm-hmm. Great.
Just quickly, I raised this. Sorry, go
ahead.
Sorry.
No, I was just saying we participate with the NVMe standards body pretty intensively. We have some serious brains working with the industry on that. So we're actually in a position that kind of brings some of that perspective into this contribution. Go ahead, Lee.
Yeah, sorry. Just to go back to the healing agent and the actual flow here. Thinking about this again, I raised earlier that you could hit a known compute issue, a known Nova issue. So the healing agent will rebuild parts of the RAID based on new connections, right, to new volumes on your backend. That they're not going to be represented in the connection info in Nova at all until the instance is moved or live migrated. I think so. Even if you're pointing to that high level device, the RAID device on the Nova side, Nova's not going to understand if it just does like a hard reboot. The connection info it provides to OSBrick is going to be the stale original connection info essentially, because we don't reach out to Cinder to refresh any of that connection info for hard reboots. You're definitely going to hit that class of issue. That it's an issue that we hit with Ceph all the time when people change monitor IPs. I can't think of another example off the top of my head, but we probably want to raise some bugs or something on the Nova side for that, because it's long-standing technical debt on the Nova side that we don't refresh the connection info at those points. We were supposed to with the introduction of the Cinder V3 API a while ago, but it's just never been addressed. It's definitely something we could potentially look at addressing in Wallaby, but without that, you're definitely going to hit that class of issue, I think.
Yeah, we should look at that then.
Yeah. So if it gets that, it would be nice, but otherwise we would just need this thinking or yes.
But it wouldn't matter if that's synced. If all three, so if you're given, so the initial set of volumes are provided to Cinder, say, when the volume's initially created, that connection info is passed to Nova initially when we're booting the instance. That's stored in Nova's database and passed on obviously to OSBrick to connect. It does the initial connection. If over time the healing agent then replaces all three of those connections, all three of those volumes, that isn't going to be reflected in the connection info unless you do certain move operations. So yeah, the hard reboot, for example, is just going to use the old connection info. It's going to provide that to OSBrick. OSBrick is going to try and connect up the device using that connection info. But that's going to get it nowhere because on your back end, those volumes have now all been replaced and removed, and those connections are no longer valid.
So this Nova database with this connection information, that lives on the same compute node, right?
No, it's somewhere else. It's central. It's not accessible from there. It's not accessible through Brick.
So we will not be able to basically sync it from the healing agents or from Brick, which are technically.
There's no API or anything to do that at the moment. And necessarily got to get access.
But you have a
complicated to actually do it. So that's why we'll have to rely on refreshing or find a different way of doing it.
You could, if you have, since you're going to have an interaction between your OSBrick connector and your healing agent, you could actually try to do the connection with the information provided by the connector info. If you have three connections there, and suddenly one or two of them you cannot actually find them, you could go and ask the healing agent, please refresh this information. You get the new info and you do the connection. It's kind of a workaround until Nova does everything in a different way, but your driver would work fine.
There's a line here between the logical volume, which is kind of created by rating these physical volumes together, and it seems like it's the logical volume that Cinder really wants to keep track of, right? That's the connection that Cinder should.
But the connection information. The connection information is also kept and is also passed by the Cinder driver. So the connection information actually describes this physical, in a way, NVMe devices. So it's also in the.
So I was just going to say that those initial three connections are the important piece. They're the thing that Nova needs to provide to Brick, forms the initial connection, and then the RAID device on top of that is the thing that Brick then replies back to Nova with to say, this is your device, use this within the instance, or you connect this to the instance, sorry.
How does this work?
So in Ceph, we connect through the monitor IPs in Ceph, so instead of, it's proxying essentially, instead of connecting directly through to the actual volumes on the back end, we go through the monitors. So replicas, everything can move around on the back end as much as it wants. As long as the monitor IPs don't change, then we're fine. But as I said before, if the monitor IPs change, then we end up in the same situation as this. It's just with this architecture, because we're connecting directly through to those volumes, if you start chopping and changing them, then we have problems.
Yeah, it's more problematic here than Ceph. Ceph effectively has a gateway, so as long as you keep that consistent, then you're basically good. And in this case, we have to deal with every leg. So that's exactly.
You can work around. You can work around it using your healing agent as the gateway.
Yeah. Yep.
But this is definitely something we have to keep an eye on. Like Lee said, this is something we have to make sure that it actually works in those cases.
For sure. It's going to break.
Is the task to get the Brick to refresh this information? You said it was considered for Wallaby, but it didn't sound like anyone was actually working on it. Is it practical to think that could be picked up, or?
Yeah, so to be clear, it's not Brick that's refreshing things. It would be Nova and Nova Compute. Yeah, it's not something that we've got written down as something to do at the moment. So I was suggesting that we write it down, we raise it with the Nova team that I'm part of. I can definitely take that to them because it's a piece of long-term technical debt that we've had. And we can see if we can get some interest in resolving that in Wallaby. I was trying to resolve this another way with a series in Cinder to introduce a connection info flag that suggested if the volume driver was idempotent when calling initialize connection, so we could continuously refresh from that. That didn't really get anywhere. We might want to attack this a different way and just have Nova try and refresh things across, any kind of stop, start, move operation that it's not necessarily doing at the moment that would potentially resolve this. As long as Cinder kept things up to date, obviously on its side, because it has to then talk to the provisioner and ensure that its view of how your volumes are laid out is up to date as well.
Right. So we have a workaround path through our healing agent, but the long-term kind of clean path is to get the Nova team to refresh this stuff anytime anything changes.
Yeah, pretty much.
There was
and like I said,
a few years back that that I instigated within Cinder, trying to get volume drivers to be idempotent with initialized connection. And a couple of the drivers that I was maintaining at the time I had to fix because they weren't. So I'm not sure we can guarantee yet that that is even the case, unfortunately.
Okay, well maybe I need to look at that flag again then to potentially just highlight things that are so Nova knows when it's safe to actually call that repeatedly, because we would definitely need that in this situation if we're doing it on stop start and everything. Unless, I guess this is kind of off topic, but with Cinder v3, the workflow was always supposed to be that Nova would just do a get against an attachment to get an updated connection info. So maybe instead of using the initialized connection and attachment create or attachment update APIs, we just do a simple get against things. But yeah, we're going into the weeds a little bit there, I guess.
Yeah, it depends. I'm not sure if we store the connection info in the attachment record in the database. If we do, then there's a way to, I think there's just a way to fetch that instead of calling the driver's initialized connection over and over and over again. We'd have to look at that. Because I know we touched on that a little bit when John rewrote the attachment API a couple years ago now.
Yeah, I'm pretty sure we
was there then
avoid that recalling initialized connection over and over.
You'd have the same problem obviously on the Cinder side. You'd have to make sure that connection info in the DB is up to date. But yeah, that could be another way.
Is there an API for that? Is there a way for our provisioner to update Cinder's database if we change something?
No,
I don't think so.
Nothing that we actually kind of accept from drivers, because that would require a driver going to the database directly, asynchronously, and changing things. The pattern we try to use is when a method, a specific action on the driver wants to change something in the database as part of the operation, it must return the data that it wants change in the resource. And the Cinder Volume Manager code is the one that actually makes the change. So if I tell the driver initialize a connection, the driver returns the information, but it doesn't store it in the database in any way. It's the Cinder Manager, the ones that store. So we don't have that mechanism, and I'm not sure we would be happy to add in it.
Oh, right, but would there be a way to trigger the Cinder manager to ask for a refresh, right?
I think that's what Lee was trying to saying that maybe should be added to Nova.
Okay.
That way of refreshing, to make sure that the information, when you do a hard reboot, actually gets updated if necessary?
So the path would be the Cinder manager would have the Cinder driver send a request to our provisioner to say, okay, refresh. Tell me again what the physical connections are for this logical volume, and would be able to get an updated view of that. Do I understand that correctly?
Yes, but that could need to be triggered by Nova on a specific
right.
situations. But yeah, that could be it. Is this volume attached to this host? Please give me an updated connection info.
Right, okay.
There is an API in the V3 attachment API. Sean provided a link there for updating an attachment from Nova to Cinder, and it provides the connector information that Cinder actually stores in the attachment database. But I'm not sure there's a way to actually get the connection info, and that's the information that comes back from the Cinder driver at the time Nova's requesting an attachment to be made.
Yeah, so that's actually returned as part of that API, the attachment update API. But the problem is that the way that's implemented in a lot of the drivers is it's actually calling initialized connection in the drivers to do that.
Yeah.
And so that's where the idempotency comes in, because that's the, you can use that initially to attach a volume, to map a volume and everything. But repeated calls to that is, sometimes it's idempotent, sometimes it's not, depending on the backend driver. So it sounds like that needs to be addressed to allow, this situation to be resolved across the board. Obviously, for this driver, it could easily be implemented in an idempotent way. The problem is that Nova would need this to work across all volume backends, so we can just do things in a generic way. I think we've got a way forward here. I've written down a quick one line in the tech debt section of the Nova PTG Etherpad for tomorrow. I think it starts at 1 p.m. UTC, but it's at the bottom of the pad, so we probably won't get there until closer to 3. But yeah, I'll bring it up there and see if I can get some buy-in on the Nova side to address this in Wallaby. We'll start addressing it.
Do you want me and Zohar to listen in on that?
Oh, you're more than welcome, obviously, but like I said, it's at the end of the pad for that section at the moment, so it's anyone's guess when it will come up. But yeah, you're more than welcome to join, and I'll definitely reference this whole use case as a driving force behind it.
Cool.
Thanks, Lee.
So if the Cinder driver can return updated initialized connections, then we can basically tap into this API that you were mentioning. The block storage API v3 to basically pick up this new connection.
Unfortunately, not right now, because because your driver will be able to do it. A couple of drivers, Walter modified also, but the rest we don't know. So Nova cannot just assume that every driver does the right thing. That's a problem.
So, sorry, I think he was suggesting is a workaround through the healing agent. Is that what you were suggesting? You'd be able to call that API?
Yes. So, well, I mean, the healing agent does the changes, but let's say we do the code reboot, right? And then instead of reading the data that's stored in Nova database, which kept only the connection information of all the replicas from the creation phase, instead, we can have the OSBrick connector cross-reference that with hopefully what is the updated connection information received via this API. This is basically a workaround that can live in the connector.
Yeah, unlikely, because we are adding things that shouldn't be happening, like OSBrick calling an OpenStack service. It's a library, so it should get the information it gets, and that's it. That's why I like this idea of going the healing to the provisioner instead of going the healing to Cinder.
Right. Ultimately, if we have these as part of let's say, bigger layer or feature, let's say long-term plan, then maybe we can have this communication happen this way too. But right now, yeah, the best workaround, as you're saying, is probably going this way. So we have to store some information here so that we keep this up to date. And there's definitely much more to think about here. But I think we are making some good progress. Very useful.
Well, you probably won't need to store that much information in the healing agent if you provide enough information in your connection information about the volume, some unique identifier where you can actually query your provisioner, no matter what new volumes are currently forming that logical.
Yes, exactly.
Yeah, that's how it works today. Yeah, okay.
That's all right. We will have to implement this on this side. On the cold reboot. Cold reboot, because
Well, the other thing to do potentially, and I don't know why I didn't think of this earlier, is just to drop the individual information about those connections from the connection info, and just always return that unique identifier in the connection info, because it doesn't matter what node is storing them. It's always going to be correct. And then the healing agent or something looks up from the provisioner what it should actually be connecting to. That's not how we do things at the moment. But
I mean, it's just looking at the local volume. It doesn't know that one of the replicas is down. Right.
Yeah, but the scenario we're looking at is slightly different. You're doing a hard reboot, which means that Nova disconnects completely the locally attached volume, so it would destroy, close the RAID, detach the volumes, and then with the same connection information, it would try to create it again. But now, if the volume has been living for a long time, and the three volumes have been replaced, the information you have is useless, because you will not be able to get that volume back with that information. That's the scenario. It's not detaching. It's you detach and it does the right thing. It's removed. But now the connection information you have has no valid volume in there. Yes, 3 old volumes that existed, I don't know, a month ago, whatever, and now they no longer exist.
I think Gorky was suggesting that basically instead of passing the actual physical connection information, you only pass an identifier for the logical volume, and the only location where the physical connection information is stored is in the provisioner.
Right, it's a hack around.
Faster,
sorry,
but to make things faster. Sorry, please go ahead.
Yeah, sorry. I appreciate that the whole reason that we normally store this stuff in connection info is to, just speed up the whole process of connecting up volumes, so we've got things cached already. But in this instance, if we know that things are going to potentially change under our feet quite a lot, or could potentially change, and they're not going to be refreshed in Nova where they've been incorrectly cached, and Cinder as well where they've potentially been incorrectly cached, just doing the lookup every time through the provisioner, it's a hack around until the debt in Nova is removed. But it would completely, remove this whole kind of error class. So we're always looking up the latest and greatest connection info. It's the data held in connection info from the provisioner, and that's what's actually driving Brick or the CLI or whatever is actually doing the host connections there.
I think that's really worth considering. There are a bunch of other use cases we haven't talked about where we work really hard for the provisioner to be the one source of truth about where things are. And when you're, for example, migrating the initiator, there's lots of ways, if you have multiple databases or multiple cached copies, that they can get out of sync. I think this is
that's a great and that's a great workaround and idea. Instead of keeping this all of this underlying connection information that actually OpenStack should not really care about in the Nova database, we just keep the important part, which is the volume ID, and keep the source of truth in the KS provisioner. So yeah, this comes with the cost of every attach operation. We actually make a query to the KS provisioner from the brick. But besides this cost,
I mean, this is, for example, how stuff works.
We can do a hybrid where you actually, for the create, you return the information, and only if you're doing the attach and one of them doesn't work, you query the healing agent.
That's great.
You can go whatever way you prefer, but if you, however you prefer. You can do performance test and see, because I believe the common case is you will not be losing volumes left and right. Things are stable. So the common use case is everything works, the connection information is still valid. So that should be the fast path, and not get penalized because in some cases the other may happen. It's better to penalize the case when you have replaced one and be a little bit slower because you first try to connect, you see you cannot do it, and then you query, and then you fix it. I think that's probably better.
Great.
Okay, so thank you for giving us your ears for a little bit of time. Any other questions?
Okay, so we'll probably have some time on Friday if something occurs to you and you want to come back and ask some questions. But I think we went through this pretty thoroughly. I think we're all on board with basically how this should go. So
cool. Thank you.
Just one last question. You mentioned that you already have the Osprey code and the Cinder code. Is that up for review, or do you have it just locally to do your test?
It's just local, but
okay.
We'll put it up for you.
Yeah, we did set up a Kioxia GitHub account now, and we can put it up there and start to try to integrate. Yeah.
No, it was mostly to see, to have a look around.
Yeah, just
it looks like
prototype.
Yes.
Caveat emptor.
And one question, since you've been working with the NVMe or Fabric code in OSBreak, I was wondering if we actually have a bug in there or not, because reading a quick read of the code in the NVMe client in Linux made me think that we are calling directly when we detach a volume to the NVMe space disconnect, that's disconnect or whatever, and it doesn't look like the disconnect actually flashes the data. So you are losing data if you have buffers filled with data. I don't know if you know about that. I mean, I don't know if you know whether the proper detach mechanism for an NVMe volume should be first flash and then the call to disconnect.
That's a good question. I think maybe Johan. No.
May have to take a look at that. I'm not sure we.
Yeah.
Are
Creating the application.
So let's say we're detaching a volume. Do we flush the data to the volume before we detach it?
Not you. I meant this was more of a not a specific to your driver, more like what we currently have in OpenStack. As in, I looked into I looked before this meeting a little bit into NVMe, a little bit into what we have in OSBreak, and that I saw that we have a call directly when we disconnect a local volume. We call directly NVMe disconnect is the value. Then I looked into the client, the Linux NVMe client, and the disconnect doesn't seem to call flush. And there is a flush command, so it's a bit scary if we are not actually flushing.
So yeah, it's a question about NVMe in general, right? So
yeah,
I think still our team should be able to answer this at one point.
We should go look into it. Yeah.
Yeah.
Okay. Thanks.
Okay, it is an edge case in a sense. If we are detaching a volume, then maybe we're not needing it, but maybe we are needing it. So, of course, in the case of live migrate, it's needed, right? But the live migrate is handled differently, a little bit more gently.
Well, we always want to flash the data.
Yeah, it's true. In general, that's definitely should always flash, right? But if for some reason the NVMe client in Linux does not do it, there might be a reason for it. But who knows,
I think it's probably like in every single device. For example, OSBreak has a mechanism where you say force the detach, which means I don't care if I lose data, because after all, I'm going to delete this volume. For example, if Nova is using Cinder for an ephemeral volume and it has the flag delete on detach, then it can call OSBreak and say force. So, for example, if you do in iSCSI, you try to do the flash. If it doesn't work, it checks the flag and say, oh, it doesn't work, but no, the caller doesn't care. Keep on moving, and finally deletes the attachment. I assume that NVMe is the same. It has split the functionality into two, flash and detach, in case you don't care about the data anymore and you want to detach directly.
Makes sense.
For what it's worth, Gorka, I don't think Nova actually uses that flag at the moment. But QEMU will definitely flush things. I don't know how far down that flush actually ends up going, but during live migration and stuff, QEMU will try and flush things out before moving things around.
In live migration, the libvirt does the flush usually. So usually the libvirt is orchestrating all the connection and flashing and migrating the memory and everything. So it's all orchestrated by the libvirt usually.
Yeah, but libvirt will flash, and it will happen the same thing as with the multipathing. Sure, libvirt flashes, but if multipathing has no paths, it may be keeping the data in a buffer. And if you assume that everything has been buffered, by the time you start disconnecting things, you could run into a problem.
Multipathing doesn't buffer. Unless you have access from all the passes, you will not continue. This is very strict in a multipathing. There's no buffering there. You need to receive acknowledgement from all the passes.
I think
if you flash,
maybe yes. I think we're assuming that NVMe is basically smart enough to handle this, and I think that's basically what Johan is saying. So it waits for the acknowledgement. But there is another path, so that's why there's the decoupling between attachment and the flashing. So I would assume the flashing should be happening by default unless you tell it not to. So I just don't know the code.
I didn't get into the kernel code. I just got into a client code, and the client just calls like I do in iSCSI, it's the dash delete, passes a 1 to that to remove it. So I assume it will be the equivalent to iSCSI devices where delete just removes the device and doesn't do the flash. So anyway, I was just wondering if somebody knew.
Figure that out.
That could be great.
Definitely a good point. We could be aware of that for sure.
In case we're already doing it wrong in OSBreak.
Yaron, can we take an action to just go look into that and report back?
Yeah. And by the way, it's in the initiator code, I guess. So you're referring to NVMe Fabric initiator code.
Yeah, let me see if I can paste the exact code that I think. I will put it in the Etherpad.
Okay.
The OSBreak code that we are calling, and maybe the link to the CLI that calls a delete. I could probably figure out in the kernel code where the delete is actually doing the flash or not.
Yeah, so the CLI tool, I mean, that's basically the client, and then the next step is in the kernel. So that's I guess where for you're diving deep into NVMe, that's where you will find the answer.
Okay, well, that's something we can follow up on.
Yeah.
So it sounds like we're good here.
Thank you.
Josephine, are you on?
Oh, yes, I'm here.
Oh,
Can you hear
good.
me?
Okay. Yeah. Did you want to? I think let's do your topic and then we'll take like a 5-minute break. How does that sound?
Yeah, it will be a small update
Okay.
about the image encryption efforts. And I've talked to Barbican team yesterday. What happens or what we need for the image encryption is the encryption and decryption code in OSBrick. You can see a work in progress patch, which is already noted on the Etherpad. And then there's the glance part, which consists of just storing the image and registering or unregistering as a secret consumer in OpenStack. And it still has a problem in Barbican. They have all the code ready for the secret consumers, but it somehow broke their tests, so they need to add micro versions, which will hopefully be done very soon in Wallaby. And after that, it will be implemented in Castellan. So Castellan is consumed by glance, and I can finally make the glance patch work. And after that, I would go on with the work in glance in Cinder. So the consuming of encrypted images in Cinder.
Okay,
That's
great.
all. Well, right now I'm a little bit blocked by Barbican, but you can all start reviewing the OSBrick patch if you like to, and look what the decryption and encryption looks like.
Right, because the my memory is the OS brick patch is independent of the Barbican work. Is that correct?
Yeah, that's correct.
Okay. So then, right. Okay. So as long as the I guess what would push the reviews is if people are aware that the Barbican work is coming together. So that's a good update because we also want to take advantage of that to make our encryption key handling more robust on the Cinder side. So how close do you think the Barbican people are? I guess I should ask them, but did you have a sense?
They have a few patches which addresses the microversion issue, and the problem is that they never had microversions in Barbican, so they need to add that too.
Okay.
They want it to be done early in Wallaby. That's what they said yesterday.
Okay. All right, that's good to know.
Sorry if this is a silly question. What was the actual work in Barbican that you're waiting on? I didn't quite catch what that was.
It's the secret consumer API. So it's that when a service creates a secret on behalf of a user, it can register that it's what resource it's associated with, and the same thing on delete. So that way, if you go to, so I think what happens is if an actual consumer tries to delete a secret, you get a warning saying that it's been registered. And then I think an end user can override that. But at least right now, it's basically the secrets are opaque. You can, you just got a bunch of them. You just start deleting them with there's no way to track them. So that's what's going on with Barbican.
Okay, cool. No, thank you.
All right, thanks, Josephine. Yeah, so keep us posted on the Barbican work because we don't always pay as close attention to that as we could, because that will really be a push to indicate that this is actually going to happen in Wallaby and will motivate reviewers. So great, thank you. Was there anything else on your
no,
side?
I don't think so.
Okay, well, thank you for coming and updating us. Okay. Any other questions for Josephine? Okay, sounds like we're okay there. Let's go back up and catch Jay's report on the TC meeting, just to catch us up with some of the stuff we talked about yesterday. But Jay, take it away.
Sure, I can do that. So just we talked about the Wallaby goals, and following up on the PrivSep requirement, which you guys were aware of. It doesn't require that everything be coded in the best PrivSep manner. Obviously, if we have areas where we can improve, that is great. But the key is to get, basically the requirement on root wrap removed, which then I don't fully understand how that's possible when they said we can still use root wrap to escalate the PrivSep process. But it sounds like, there's some improvements that need to be made there in the future. And I don't, Walter, Eric, I think you guys have worked on this in the past. I don't fully understand how the escalation works, but it sounded like there are two ways you could go. You either, continue to start Cinder as the Cinder user and then have to escalate to start PrivSep, or you either start Cinder as root and bring up PrivSep and then de-escalate Cinder to the Cinder user. So those were the two options we discussed.
I think a root wrap is initially used to start the PrivSep daemon, which is then later used.
That's how it's normally done now. There is a whole different way we could get out of doing it that way if we wanted to, but that gets more into deployment configuration stuff, and we just haven't really into it.
Okay. So the long story short was need to remove dependency on root wrap everywhere else except for, as needed to start the PrivSep daemon if necessary. As far as there's a second now cycle goal to move to using YAML away from JSON as the default policy file format. We kind of touched on that yesterday. I don't think that's going to be a significant impact upon Cinder to get that in place, but just wanted to raise that's now a goal as well for awareness. And Gmon is heading up that goal. OpenStack client, spent the majority of our time talking about this, trying to figure out how we're going to handle it, trying not to take a stick to the projects and force anybody, but also to try to kind of continue to improve the user experience moving towards OpenStack client. So the resolution we're working on is basically a TC resolution indicating that we want to continue to move projects away from the libraries, and we're going to start by going through project documentation and see where the cases that OpenStack client or that find the cases where, for instance, the Cinder CLI is used instead of OpenStack CLI. And if the documentation can be updated to use OpenStack client, then we will do that. If not, we'll start getting a feel for how big the disconnect is there to eventually move to using just OpenStack client.
It's about moving away from CLIs, not libraries, right?
So, what's that?
This is actually about moving away from per project CLIs, right? Not libraries.
Yeah, sorry, that's misworded there.
So is there a mechanism in the OpenStack client to add plugins, such as the OS Brick plugin for Cinder?
Yes, we've got some plugin mechanism in OpenStack client.
Okay.
Is that new since we last talked?
Well, some services do that, right, where they have a plugin based on their client to enable OpenStack client functionality. But Cinder is not really well positioned for that because there's already an OpenStack volume apparatus that's not based on our client.
Oh, that's right.
But so is Nova. I mean, I think that what I heard some time ago from the Core SDK team was to try to not have plugins and rather have things inside. So I'm not sure how this is going to.
Yeah, and to answer Walter's question, I'm not sure that the plugin structure for the OpenStack client is compatible with what we want for the Brick extension. But I really don't know.
Need to check it.
Yeah, okay. And that's probably a good thing to make them aware of, that we already have an extension that's kind of necessary.
Yes,
I mean,
the whole purpose of it being that you can do volume attaches and detaches as a end user from bare metal.
So that's going to be an extra challenge to work that into the OpenStack client. Okay. I'll have to go look at we have a feature gap spreadsheet, I think, that Sean put together a while back.
Yeah, the feature gap spreadsheet is definitely useful and worth looking at again. I think a lot of that gap was based around the fact that OpenStack client was missing some microversions infrastructure that we needed. Is that still the case, we think?
So what I heard, I don't know for sure. What I heard was that they do support microversions, but not in a way that actually does what we need. So I don't know what that means.
I think it's true they support them for some services, but there was some building block that was missing that we needed for them to work in the Cinder part of the client.
Yeah, and I think that's still true.
And I think we've been waiting for a few years for that gap to get fixed on the OpenStack client side.
Yeah, I'll take an action item, Jay, if you don't mind typing it in, to just review the feature gap sheet and then talk to figure out what the status of microversions is right now in OpenStack client.
As I remember, they've got implemented microversions.
I'm sorry, Ivan, I didn't catch that.
As I remember, OpenStack client supports microversions, starting Stein or Ursula release.
Okay, so okay.
It in theory supports microversions in general, but I think you can't actually use them with Cinder right now, if I remember correctly. That was at least the case a while ago.
Yeah, so it may have changed. All right, so I'll take a look at that. So we're not clear right now what the microversion status is. Okay. And then I'll have to talk to somebody over there. I guess my impression was Stephen Finucane is sort of leading this effort. Maybe I'll talk to him about the OS Brick Cinder client extension to make sure that he's aware. Let me put that as another one. Okay, great.
And Kendall was attending their meeting today and going to get some more information from the OSC SDK team. So if I hear more, we'll follow up on that in the TC meeting on Friday. So if I have more information there, I'll let you guys know in next week's meeting or something.
right, so it looks like some kind of note stuff. All right, that'll be good to follow up. Any questions for Jay about what's the TC up to, just in general? They're meeting on Friday.
Yeah. So, I won't be able to join here on Friday. We're meeting at noon, as a TC group. I don't know if it will actually go that long because we got through a lot of the topics yesterday, but who knows?
All right, so 15. Okay, so we're supposed to meet with Glance at the bottom of the hour, so I guess we should move along.
Thanks.
Thanks for the update. Now I'm not saying that in terms of you should shut up. I'm saying it in terms of I'm going to skip the break I was going to say we should take. Although Blue Jeans it breaks the recording at 2 hours, so I'm going to turn off. So tell you what, let's take a. I'm afraid to say take a break, but nobody can get caught in the hallway because nobody's in the hallway. So let's. It's 14:59 right now, so let's start again at 15:05 UTC. So let's take a break. I'm going to stop the recording and I'll start up again. All right, thanks. And then Sophia, you'll be up when we come back. Okay, great. Thanks.
Okay, thanks.